Here it comes. Okay, here we go. All right, so what I want us to do first for this first one is I just want you to graph all those points. Okay, as many as you can. Some of them will not fit on the graph. Okay, so just graph those points for me. You're on the wrong side, I think.
Oh.
Alright. So just graph those points for me. As many of them as will fit. Okay. So you can really only graph those first 3 points, right? So if we draw a line through those points right there, that will give us this. And so we need to know the equation of that line. Okay, Aiden, what is it? Okay, y equals 2 plus 4x. You guys agree? Okay, I almost thought he was wrong for a second there. Because I was thinking he was saying the slope is 2. What's another way some of you might write that? 4x plus 2 is also acceptable. Either is fine. It's more likely, like answer choices a lot of times have the x first, so it might be a little more likely for you to see that if it's multiple choice. But either one is fine. Now, let's stop and think about how the table relates to the graph, which relates to our equation. Okay? Because sometimes we're going to get numbers where we're not going to be able to graph them very well. Right? So our goal here is to be able to do this straight from the table instead of having to graph it first, then do the equation. So let's talk about slope first. We've already done slope from a table a little bit. What do we do to find slope from a table? Mx plus b is how we write the equation here at the end. What did we do to find the slope from a table? We looked at what was happening on each side, right? What was, how much we were increasing by. So if we look right here, we go to from 2 to 6, we're going up 4. From 6 to 10, we're going up 4. We could keep going, but they're all going to be the same. You just keep going up 4. Over here on the left-hand side, how much are we going up by? 1. And so our slope is our change in y over our change in x. The change in y is this right-hand side, which is the 4. The change in x is the left-hand side, which is 1, so we just get 4 for our slope. All right, so y-intercept. For our y-intercept, how can we find that just from the table? What do you think, Aiden? Okay, so definitely like on the graph right here, that y across the y-axis too. How can I tell that's going to be it when I look at the table? Anybody know? I mean, you know there's going to be a y-intercept because it's linear, but you don't know exactly what it is. All right, I'm not going to tell you right now because we got some more problems that we're going to graph. But just note that right here, too, was your y-intercept. And think about your table. So we're going to do another one, and then we'll think about what's going to happen. So I've got these points. We want to graph these as well. So we got 0, -2, 1, -1.5, so that would be right here. 2, -1. 3, -0.5, 4, 0, 5.5. So if we draw our line in here, here's what we've got. Okay, so if we graph this, then we can think about what our equation is going to be. Isabella, what do you think the equation for that line is going to be? What is the 0.5 going to be? Is that your slope or your y-intercept? Okay. And then what's the y-intercept? If we look at our graph, where do we hit the y-axis? -2. Okay, this is fine. You also could just say y equals 1/2 x minus 2 because 1/2 is the same as 0.5. And a lot of times we like fractions better whenever we're dealing with slopes. So this is the correct line. So let's think slope that we were doing earlier. If I go from -2 to -1.5, what did I do right there? You add 0.5. Sometimes it's hard to tell with the negatives. If you want, you can skip down here from 0 to 1, from 0 to 0.5. That's much clearer. That's adding 0.5, right? What's happening over here on the left-hand side? You're going up by 1, so your change in y over change in x is going to be 0.5 over 1, which will give you 0.5, or if you would rather, you can do 1/2. So there's our slope. All right, this time our y-intercept was -2. Any ideas on how we can tell that from the table? What you think, Aiden? So the x was 0, my y was -2. This ended up being my y-intercept. Was that the same on the last problem? Would that hold true for the last problem? It would. That was our y-intercept, right? That looks promising. Let's see if it happens on the next one. Oh, I don't know what that just did. Okay, so let's keep that in the back of our mind. It's looking like maybe if the x is 0, then the y is our y-intercept. Okay, let's graph these. I might have this one messed up. Oh wait, I graphed this down as -4.5%. Let me fix it here. Yeah, I was looking very wrong, wasn't it? That looks prettier. Okay, those are lining up, right? All right, so Ian, for this one, what would our equation be? Okay, you guys agree? I think that looks good. Slope is 1/2. y-intercept is 7. Let's test Aiden's idea about the y-intercept. He said that when the x is 0, that y is your y-intercept. Is that true on this one? It is. This is our y-intercept. In fact, Aiden is exactly right. If x equals 0 in the table, that point is your y-intercept. Oh, I just typed that. Kelly, could you let Hunter in there? You got your water bottle? Yeah. Okay. That's not his. That's one of my soccer moms in second period left their snack baggies in here on accident. Had a little cooler full of snacks that they were carrying around to be. And do you have snacks too on you? Yeah, like a good soccer mom. All right. Okay, so this is always going to be true. So when we're looking for a y-intercept, we want to see where the x equals 0, and that's going to give us our y-intercept. Slope on this one, you can pick any 2 points. Here, your change in y would be up 0.5. Right here, you go up 1. So you change in y over change in x is your slope. That's 0.5 over 1, which is just 0.5, so, or 1/2 for that. So if we were doing it without a graph, we could do that as well. We okay here? All right. Okay. Let's graph as much of this one as we can. This is the last one we're going to graph. -1, -6, 2, 0, 4, 4, 5, 6, 8, 12, and 10, 16 won't fit on this particular graph. Okay, I think that's pretty good. Okay, can you find the y-intercept from this table? Yeah. What would it be?
Oh, wait. No, you can't find it.
It kind of looks like it should be 2, right? But it's not. What is 2? That's right. At 2, 0, that point is your x-intercept, right? The actual y-intercept is -4. So, so our equation y equals, we'll have -4 over here. What's the slope, Eddie? It's y-intercept. What's our slope? What? Not 1 over 2. You got it backwards. 2 over 1. So just 2x. Because you're going up 2 to the right 1. You always got to go up or down first, right? Yeah. So up 2, right 1, slope of 2 over 1. If you're doing it from the table, sometimes it's hard to do with the negative numbers. Unless it's asked you if it's linear. For these, assume it is linear because it told you right the equation of the line. So if you don't want to deal with that negative, go down here to some of the easier ones. From 0 to 4, what did you do? Up 4, from 2 to 4, up 2, so you're changing y over changing x would be 4 over 2, which is 2. There. Now that one we could not find the y-intercept from the table as we were given the table anyway. Okay, questions? All right, let's try some without graphing. So sometimes they're just too big to graph, or maybe we don't want to graph, and we need to go from the table to the equation. Now, good news is if numbers are small enough, you get graph paper on that final exam, and I will give you graph paper anytime you would like on the test if you so desire. Or if we're using whiteboards, the back side of the whiteboards are all graph paper, right? So you can always graph stuff if you so choose. Sometimes the numbers are too big to deal with, though, so that can be an issue that we run into. So, do we know the y-intercept on this one? We know it. What is it, Aiden? Is 40. When your x equals 0, the y, there is your y-intercept. So this is where our y-intercept is at. Okay? So our y-intercept is going to be 40. Okay? Then we need to know our slope. So Haley, how are we going to find our slope? It's not just our x-coordinate. Okay? Slope is our rise over our run, our change in y over our change in x, right? So if we're looking for change in y over change in x, if I go from 40 down here to 20, what happened to my y? Subtracted how much? 20. So I went down 20, right? So my change in y is negative 20. What's my change in x? From 0 to 1, what did I do to my x? Added how many? 1. So negative 20 over positive 1, what does that give us? Negative 20. And so this is our slope. So Haley, if we have a slope of negative 20 and a y-intercept at 40, what's the equation of the line going to look like? Not 1. What's our y-intercept? The y-intercept, we're going to find it's wherever x equals 0, it's the y-coordinate that goes with it. Right? So it's going to be that 40, so we'll have plus 40. So y equals negative 20x plus 40 would be our equation. So for tables, wherever your x equals 0, that's your y-intercept. And then for your slope, you need to change in y over change in x. Okay? Questions? All right, let's try another one. All right. So, for number 6, Rosalind, what is the y-intercept going to be? Okay, it is going to be 5. I find that by looking right here. Wherever the x equals 0, that y-coordinate right there is my y-intercept. Okay? Then I need to think about changing y over changing x. So Blakeland, when I go from 5 to 2, what's happening there? Subtracting 3, so that's my change in y. Right, that's the y. And then from 0 to 1, what am I doing? Plus 1, that's my change in x. So negative 3 over 1 is just negative 3. So I have a y-intercept of 5, a slope of negative 3. What's that equation going to be, Blakeland? we just put the negative 3 instead of putting it over 1. So we'll have just y equals negative 3x plus 5. Very good. Okay. You can put it over 1, but Delta Math really doesn't usually like it when we do that, and it's not necessary. There. Okay, here. All right, and so we know the y-intercept for number 7. Okay, very good. Gracious me, this is so annoying. Why will it not work? Okay, we get that from right here. That 6 is going to be our y-intercept. All right, Lexi, when we look at our slope, we're going to do change in y over change in x. So if I go from 14 down to 6, what's happened there? Minus 8. So that's my change in y. And then from negative 2 to 0, that is plus 2. So negative 8 over 2, what's that going to give us for our slope, Lexi? Negative 4. Isabella, what's the equation going to look like for that one?
Y equals negative 8 plus 6. Negative 8x.
You do need x, but not negative 8. Negative 4x plus 6. Because that negative 8, there we got to do negative 8 over 2, which gives us negative 4. Okay here? Alright, some of you not writing anything down. Guess you already know how to do it. Uh-oh. Oh no. Look at these next two. Do we have the y-intercepts for either one of these next two? No. Okay, so if I need the y-intercepts, then that means I need to know where x is 0, right? So what I'm going to do for these is I need x, y. I need 0, 1, 2, 3. That'll be good enough, right? 2 I know is 15. 3 is 34. If I wanted to, I could keep on going, put 4 and 5 on there. But the main thing is I need these two terms. And well, I don't need 1, but I'm gonna have to find 1 in order to be able to do 0 right here. So let's go ahead and do our slope. Okay. So to get from 15 to 34, what are we doing? Adding 19 from 2 to 3, 1. So our change in y over our change in x, our slope is going to be 19 over 1, which is just 19. So to get to the next number, you just keep adding 19, right? So 34 plus 19 is going to give you 53. 53 plus 19 will give you 72. We don't need to get the higher numbers, right? What do we need? Lower numbers. We need to go backwards. So how are we going to go from here to here? We'll subtract 19. What's that going to give us? Negative 4. And then we would need to subtract 19 again. Negative 23. So right there is my y-intercept. So Riley, what is my equation going to be here? It's going to be y equals mx plus b, so we need the slope. What was our slope? 19. So I'll have 19, and the x goes with that. And then we need to put the y-intercept on the end. What's that going to be? Okay. Y-intercept is where the x equals 0. So it'll be negative 23. So we'll have minus 23. And that'll be our answer there. Okay there? Oh, gracious me. This one is terribly annoying because I've got 1, 3, 5, 7. Not only is my 0 missing, I'm skipping numbers, right? So let's do this. Let's draw us a chart, X, Y, and let's go 0, 1, 2, 3, 4, 5. That'll be good enough, right? So if I put the numbers that I know already, 1 is 8, so 1, 8 goes right here. And 3 is 0, so 3, 0. And 5, negative 8. So what would be helpful to do is like fill in the numbers that go in these gaps here. So if this is 8 and this is 0, what number goes in between? 4 should be right here. And then what number should be right here? Negative 4. So if we're thinking about our slope, what's happening each time? What are we doing to our x values? Decreasing by 4. And then over here, up by 1. So we get negative 4 over 1, which is negative 4 for our change in y over change in x. So our slope is negative 4. The y-intercept we do not have. What should we do to find the y-intercept? We need to add 4 to that 8. That will give us 12. So our y-intercept is right here. Lanaya, what is our equation going to look like?
Y equals negative 4x plus 12.
Perfect. Negative 4x plus 12. So when you are missing numbers in your table, you want to try to fill in the numbers that are missing. Particularly, you need the 0 something. Now, you could do slope from the original table. If I go from 8 to 0, what's that? Minus 8. And 1 to 3 is 2, right? So if I do negative 8 over 2, I still get negative 4, which is the same slope. So you can use any 2 points. It's okay. You could still, if they only ask you for slope, you would not need to find the missing numbers. But because you need slope and y-intercept, you got to find those missing numbers there. All right, 2 more. And these start to get important for several things. These are kind of simple situations that I have created, but they can become important whenever you apply them to bigger situations. So the table below gives the balance B in a bank account after M months. And then you got your months and your balance. What's the word balance mean? The amount of money in the account, right? So how much money is actually in the account. So if your balance is $110, you have $110 in there that you can spend. If your balance is negative 5, you're in trouble. So we need to write an equation for this situation. Now, notice here they told you that the balance, excuse me, is capital B. So that this part right here is capital B. And what did they tell us months is? What letter did they use there? M. So we want to use an M right here. Normally, we'd use X's and Y's, right? But instead of the Y, we're going to do a B because they told us to use a B for balance. So we're going to do capital B equals instead of Y equals. And then M is we're going to use that in place of our X. Okay? So we need slope and y-intercept. Kaylee, can we tell the y-intercept from this table that we have here? Okay, what is it? 20. Right here, our X, or in this case M, is 0. So our y-intercept is 20, or I guess it's really your M-intercept. The intercept right there is 20. We also need our slope. Giancarlo, when we look at slope, we're doing change in y over change in x. What's happening each time? What's our change in y? Adding 15. So that's our top number. And from 1 to 2, what's happening there? Adding 1. So we're just getting 15 there, which makes sense. It's $15 a month, right? That's your rate of change that you've got there. So the slope is 15. We're going to put an m next to it instead of an x because they told us to use an m for our variable. And then our y-intercept is 20, so 20. So here is where this is useful. If I want to know how much money is going to be in this account, I can just use that equation rather than like trying to count up, right? So I could extend this equation all the way out to this table all the way out to 23 months and just keep adding 15 over and over and over again. But that will take a little while. So if I want to know how much money's in the account after 23 months, what should I do, Evan?
Multiply by 15 and add 20.
Okay, and what I'm doing is I'm plugging 23 in for the m, right? Because that's our number of months. So we'll have 15 times 23 plus 20. And Evan, have you already done 15 times 23?
15 times 23, no, I did something else.
Okay.
I just did 15 times 20.
What'd you get? 115. Let's double check it. 15, carry the 1, 10, 11. Oh, I don't think you did it right. You forgot to do the... Oh, yeah, that sounds better. And then 3, and then 2. Yeah, 345. Sounds good. So we got 345 plus 20, and that is going to be 365. So after 23 months, you'd have $365. So writing equations is helpful because you can make predictions about the future, right? Because you know that if this is going to be the case, if you're going to keep putting $15 in this account every month, this is going to keep continuing on, and then you can make predictions about how much money you'll have in the future. So it's useful there. All right, last one. We're going to do some practice. Riley has been tracking the amount of weight that he is able to bench press in the table below. Good thing I said bench press instead of squat. That would have been really funny if I said squat on this one, because he's not squatting much right now, I'm sure. So week 0 he benched 135. Second week 140. Fourth week 145. Sixth week 150. Riley is getting strong here. So we need to write an equation that gives the weight he can bench press after X weeks. And it tells us W is our variable for weight and X is our variable for weeks. So we'll have a W here instead of a Y, but we'll still use an X for the weeks because that's what it told us to use. So we are looking for W equals... Eddie, can we tell the y-intercept for this from this one? What is it? Whenever we're looking for our y-intercept, our x-coordinate, what's it going to equal? 0, right? So our x-coordinate equals 0 right here. So this right here is your y-intercept, or in this case, I guess it's your w-intercept since we're using w instead. So this is our y-intercept right here. Okay. For our slope, I think when you said 5, you were probably thinking slope. Right? Slope is where we look at the change in what's happening. So change in y over change in x. So from 135 to 140, what was that? That was up 5, right? So that's up 5 over, okay, this is up 2. How could we summarize like that? What would we say is happening? What's Riley? Yeah, every 2 weeks he's benching 5 more pounds, right? So I can leave this 5 over 2 if I want. Sometimes I would rather have decimals. In this particular case, you could also make it 2.5, so 2.5 pounds every week. Either way is fine. I guess we'll just do 5 halves. So 5 halves x plus 135. Okay. So let's say that Riley's goal is to bench press 200 pounds. So if he wants to be able to bench press 200 pounds, which is a lot of weight, Riley can bench press 200 pounds. I will be impressed with him. Maybe one day. So if he can bench, if we want to know when he can bench 200, where would we plug the 200 in here? What do you think, Aiden? We got to plug it in for the W because that stands for weight, correct? So this is different than the last problem we did. We would do 200 equals, I really feel like I'd rather have a decimal there. You guys okay if I make that 2.5? Let's do that. You can do it with a fraction also, but let's do decimal. So I need to solve this equation for the x. It's a little harder to do than the last one that we did. So Cam, if we're going to solve this for x, what would we do? Perfect. Subtract that 135. And that is going to give us 65 equals 2.5x. And then what would we do after that, Kama? And we've gone too far without a calculator for me to give you one now. We can do it. It's the last question. What have I got to do with that decimal? Move it over, and if I move it over, I got to move this one over. All right, so 25 goes into 65 how many times? 2 times 2 times 25 is 50. We would subtract. We'll get 15. We will bring down that 0. How many times does 25 go into 150? 6. 6 times 25 would be 150. So you wouldn't have any more range. So it'd be 26. So 26 weeks, which is exactly half a year, which I feel like is probably unrealistic. 26 weeks to go from benching 135 to 200. That's a lot of extra weight. I think it would depend on a lot of factors. It would depend on whether Riley's already kind of buff and let's say Riley is like super weak. I'm sorry for you. If he is super weak but has potential, this might be possible. Like if he's not been doing any exercise, even though that would also mean he has to be able to bench 135. So it's possible. But it's probably going to be more logarithmic. It's probably going to flatten out. Yeah, because you're probably going to have bigger gains at first, and then as you kind of reach your maximum, like for example, there's probably, a person, Riley's size is probably only going to be able to bench so much. So it's probably going to start off a little bit faster at first and then slow down. That's probably what we're going to see. All right, so